The action potential can be divided into 6 phases: an initial steady state or resting phase, a rising phase, the overshoot phase, the falling phase, the undershoot phase, and the recovery phase. We'll now examine each of these phases in turn. When a neuron is at rest, only the so-called leak potassium channels are open, establishing the resting potential. These potassium channels, a subset of all potassium channels, are constantly in the open state. During the rising phase, the increasing positive shift in membrane potential is driven by the opening of progressively more and more voltage-gated sodium channels and the entry of sodium ions into the neuron. This inward sodium current depolarizes the membrane voltage, as indicated by the red color shift in the membrane. The membrane potential is now at its most positive state. It is overshot 0 millivolts. At this positive potential, 2 processes are occurring simultaneously. First, the voltage-gated sodium channels that initially activated during the rising phase begin to close. As a result, sodium conductance starts to decline. Next, potassium channels begin to open, driving the membrane potential back toward the equilibrium potential for potassium. These voltage-gated potassium channels differ from leak potassium channels in that they are normally closed at the resting potential but open in response to depolarization, thus the term voltage-gated. Now, the action potential is in its repolarizing phase, i.e., the membrane potential is rapidly returning to the resting potential. During the falling phase, activation of voltage-gated potassium channels is at maximum, and the number of open sodium channels is dramatically reduced. At this stage, the action potential repolarizes beyond the resting membrane voltage. This hyperpolarization is indicated by the blue color of the membrane. The undershoot occurs because most voltage-gated potassium channels are still open, such that the total potassium conductance of the neuron is greater than when the membrane is at its resting steady state. During the recovery phase, the membrane potential returns to the original steady state resting potential. This occurs as the delayed potassium channels that were open during the action potential now close. The membrane potential is now determined by the other channels normally open at the resting potential. In fact, the transition between the phases of the action potential is seamless, and one stage grades smoothly into the next.